the course of intermediate econometrics. Basically, it contains some basic portions and some of the higher things that we require to read. Okay, all right. So before starting the course, I had mailed you regarding reading the appendix of or from the book Christopher Woolridge. How many of you did that?
I did, sir.
Anyone? Okay, thank you so much. Anyone else?
Not completely, but yeah, halfway.
Okay, thank you. Thank you. Thank you so much. And do you understand the reason why I asked you to go through those chapters?
Yes, sir. Those are the basic concepts needed.
Correct. And those are the things which are precisely required while we undertake this course. And we will take this course, we'll try to read assumptions part in matrices form, and then we'll also solve certain questions on Excel or R, whichever software that we find comfortable with. And the second thing is that please don't treat this course as something which is tough or which is difficult, because once you enjoy learning this course, then it will be really helpful in all the fields. At least precisely it is a subject of econometrics where an economics graduate and an engineering graduates or other field, we have slightly, or you can say better advantage. We are at an advantageous position when we have to interpret these equations, because otherwise statistics and other related aspects are easily covered in all other disciplines as well. But econometrics, if you learn econometrics or if you understand where to apply these concepts, because nowadays we do not solve any of these things manually. There are dedicated softwares for all this, and once you join, or once you whether you join a research think tank or go for a corporate company, they already have a well-defined process. They all have softwares related to econometric applications, but where we add value to such field is how to interpret or what test to use, which are the tests which will be useful, which are the tests which cannot be used. The assumptions required to go for any application related problems. And I'm sure that you are aware of something which is a very common interview question. They are called guesstimates. And guesstimates precisely, if you learn the basics of econometrics, you'll be able to answer all those guesstimates questions, because ultimately it is about estimating and the best guess that you can have about, or that you can have for one particular problem that has been assigned to you. So that's how we'll go, and the main reference for your course would be, it's a very basic book, but still it will be a good book. Those who have not learned econometrics pehle, and those who have, that will also help you. So you can read Woolridge Introductory Econometrics. Those who want to read or understand a little bit higher, you must think about reading William Green, again a very good textbook. Then you can read Introduction to Econometrics by J.S. Madala, one of very fine Indian econometrician, and he has written this book way long way back, but the book contains really good concepts. And it will be an earnest request that you learn any software, agar aapko R mein comfortable hai, because R is mainly used for statistical software. So, and there are various online resources available where you can learn R easily, and R is for free. And why I request you to learn R is because, this will add an additional point in your CV, because knowledge of software and application of these softwares are very much required apart from whatever degrees that you have had. So ये request रहेगा आप सबसे just out of your own interest, please learn at least some basic portions of R where you can at least present yourself in any interview or in any field where you go after your post graduation. It will be really helpful if you learn at least one software. So I'm not saying only R. If interest अगर आपको है तो आप Python भी सीख सकते हो. But R थोड़ा easy है और R easily available और free है online. You have Data Camp, you have Udemy, you have there are other resources available as well. Also YouTube में बहुत सारे आपको lectures R पे मिल जाएंगे. So and Christopher Woodley's के जितने computer exercises question है, at least I'll request you all to go through or solve those questions using or on R. Because manually these problems are not solved, and so I'll also not ask you to solve these questions manually. But where our understanding will be that how do we interpret whatever results that we have got, whether those results are consistent or not. If they are consistent, good. If they are not consistent, what all methods you can suggest. That's all that you need to learn in econometrics. Okay, so these are the things which are pre-essential requirements for the course and also for your own understanding. तो समय मिलेगा आप at least just devote 15-20 minutes every day on learning any software. Excel में भी होते हैं सारी चीजें, but Excel में थोड़ा tedious होता है. That's why I'm asking you to learn R. And once you learn, and it is not necessary that you learn to code these things altogether totally. Just basic understanding of R and application of econometrics using R software will take you places, at least after post-graduation. Okay, all right. And the other thing is that it is not compulsory. Some initial lectures you can find also on my YouTube channel, which I have not updated for long time now, because I have not got time. So for the initial portion, you can also go through my lectures on the channel, but it is not compulsory. I cannot ask you to go through that because there are plenty of resources available online. It depends on you totally whether you wish to read from there. But that's also free. You must go through if you like. You can go through those lectures. Okay, all right.
Sir,
Yeah.
sir, I had one doubt.
Haji.
Will we do any of those R exercises in class?
We have to do now because all those computer exercises we'll try to do on R. At least Woolrich ke jitne questions hai, yeah, econometrics with examples by Gujarati, not basic econometrics by Damodar Gujarati. Econometrics with examples by Gujarati contains lots of practical examples and with data. So that's what I'm saying. Like we'll learn those theoretical concepts and try to apply those things using these software in our class. So, and once you learn the software, then it will be really easy for me to, take the course at a much faster pace. Because I'll not be able to teach you, how to, use R, because it will take a lot of time. So if you do it yourself, at least if there are really complex questions, obviously I'll be solving those things. But at least basic portion hai, I'll request you to learn yourself, and trust me, it will be really helpful. Whether you're vying for placement or any research think tank as well, if you're interested in going for academics. Otherwise, econometrics का कोई खास application होगा नहीं अगर आप इन दोनों अगर आप विदाउट सॉफ्टवेयर आप सीखते हो तो, बिकॉज थियोरेटिकली इट डज नॉट मेक मोर सेंस. थियोरेटिकली सिर्फ पढ़ाने के लिए इजी है, समझने के लिए भी इजी है, बट उसको अप्लाई करने के लिए वी मस्ट लर्न हाउ टू यूज दिस सॉफ्टवेयर्स. सो yeah, we'll solve those computer exercises, at least 2 or 3 exercises from each chapter, so that you understand how to go about these things. Okay, all right. Is there any other question before I move ahead?
Sir, could you
Please
read
start
the book
recording
name
this
again?
lecture.
Oh, yeah. Right.
Sir,
Yeah.
could you please repeat the book's name again?
Christopher Woolridge, Introductory Econometrics. This book you can read for a very, complete understanding. Book बहुत easy है, बहुत simple है पढ़ने में. And once you are comfortable with reading this book, then you can go for either reading Introduction to Econometrics by G.S. Madala and विलियम ग्रीन का बुक है इकोनोमेट्रिक एनालिसिस करके. However, this textbook, though is really a wonderful textbook, but it थोड़ा सा उसमें maths and matrices methods ज़्यादा used है. So that's why I'm saying that first go through Woolridge, and if you're comfortable with reading chapters from Woolridge, then I'll request you to shift to G.S. Madala. बट अगेन ऐसा कुछ नहीं है कि आप वुलरिज में वो चीज समझ नहीं पाओगे जो जीएस मडाला में ज्यादा अच्छे समझ सकते हो. बट जीएस मडाला एक्चुअली टेक्स्ट बुक जो और भी कॉम्पैक्ट अंडरस्टैंडिंग एंड अ बेटर व्यू ऑफ you can think like that. And once you're comfortable with reading all these two textbooks, then I'll request you to go through William Green, that is Econometric Analysis by William Green. A very good book. It is referred in almost all US universities, and also some of the companies like Deloitte, Citibank, they ask you, once you join these companies, they ask you to go through this textbook altogether. At least first few chapters, first 4 or 5 chapters, they ask you to go through, so that they do not need to invest a lot of time in making you understand how to think about these econometric applications. ठीक है?
And sir, R means basically we have to focus on the application of econometrics part, right?
Come again, Himani, what you're saying?
R means like we have to basically focus on application of econometrics, na? Because
Correct,
what
correct,
about R
correct.
we have done in statistics as well.
No. You see, R में एक तो like if you're solving manually, we should be able to solve on R first thing. Second thing, we'll try to interpret the output that comes out of these software. Because anyway, these you will not calculate manually. They will be presented in front of you, and then you are asked questions on those things. इसका क्या मतलब है, coefficient का क्या मतलब है, coefficient insignificant is significant. These are things that will be required. So don't worry. I'll teach this subject thinking in my mind that you have to answer, or in interviews these will be important. So yeah. And R will just be an added thing on your CV, nothing else. Because you understand that there are so many other students also who pursue post-graduation or graduation and post-graduation with other subjects. So where your CV looks a bit different is your knowledge and your understanding of one of the software. And R is easily available. That's why I'm focusing on R. Otherwise, if you're interested, you can use any software, as long as you find it really comfortable. ठीक है?
Yes, sir. Thank you.
Okay. So shall we move ahead and start the course?
Yes, sir.
Okay.
Yes, sir.
हाँ जी. Okay. एक और चीज बोलना चाहूंगा, like if you really go through the syllabus, I don't know how many of you have gone through the syllabus as of now. So if you go through the syllabus has lot many things, and if we just follow, or if we just go word by word of the syllabus, then it will be really difficult for us to keep our head in one place. So what I'll do is I'll cover all these aspects, but I'll be focusing more on all those important aspects which are very much necessary. And जो चीजें मुझे लगेंगी कि आप खुद से पढ़ सकते हो, I'll ask you to read those things yourself. So that's it. That was all that I had to say. Let us start now.
Sir, one last question.
हाँ जी.
Sir, will we have any projects जो हम R पे कर सके?
You see, projects as such, I don't know how many projects I'll be able to give you, but questions definitely we should solve on R. Like, जितने back-end questions हैं voltage के, especially computer exercises, because they are purposely given for that purpose. And also the questions which are given in the chapter end problems of econometrics by examples by Damodar Gujarati. So दामोदर गुजराती का एक कंपेनियन वेबसाइट है, उसमें वो सारे डेटा सेट्स हैं जो कि उस बुक के लिए यूज्ड हैं या उन क्वेश्चंस को यूज करने के लिए होगा. सो विल हैव ऑल द डेटा सेट्स. वी मस्ट नो हाउ टू अप्लाई और व्हाट ऑल टेस्ट और which all models will be able to apply to all those data sets. So mostly we'll treat those questions as our projects, and once you get real life examples, then you'll be easily able to handle all those aspects as well. So basically chapter and problems of Woolrich and Gujarati will be our all those problems or exercises of econometrics using R. Chalega?
Yes, sir. Got it.
Yeah. Okay, all right. So without further delay, let us start. And again, a request, please enjoy learning this course. And I'm sure that you'll never find any difficulty as far as econometrics will be concerned. Okay. So a very cliche question, but a very important question again. What exactly is econometrics? How do you understand econometrics? Anyone?
Sir, it is estimation of economic laws using statistical and mathematical concepts.
Mm-hmm. Correct. Okay. Anyone else? Please, guys, please speak up. जो भी आता है वो बोलो आप. What essentially is econometrics? How many of you have had econometrics in your undergrad class? I presume that those coming from DU or Symbiosis, they would have had econometrics course. Okay. Thank you. So essentially क्या है econometrics? क्या लगता है आपको? What this subject is all about?
So it basically describes economics, present economics in mathematical terms.
Complete money?
It basically presents economics in mathematical terms.
Sir, can I give a try?
Yeah, please go on.
Econometrics from my side would be estimation of something that we could predict about future.
Predict about future?
Yeah.
Okay.
Based on the data available to us from the past, we try to estimate the future value of anything, by it be the marginal rate of consumption and all this.
Okay. Anyone else would like to try?
Sir, as per my point of view, sir, econometrics is like we have an economics theory. We write it in a mathematical form, and we use the statistical interference and the empirical data to prove that economics law, either we reject or accept that law, as per my point of view, sir.
Correct. Yeah.
Also, it can either stats can either be descriptive or analytical, and this is the application of the analytical side.
Correct. Very good. Others, please say anything that comes to your mind. At least speak.
So in econometrics, we usually try to minimize the error term.
Very good point, but we have not come to error terms at all. But it's a good point. Basically, entire econometrics is about understanding how error terms behave, and I'm really thankful that you have brought this point. Really thankful. Thank you.
Thank you, sir.
Okay, you see, many of you talked about application of statistical and mathematical tools for economics and economic data and all. But where precisely econometrics is offered or should be understood as a separate subject, and why it is different from mathematical methods and statistical methods? Because we also have mathematical methods of solving those economics problems. We also have statistical methods of solving those economic problems. But why why specifically we need econometrics then? And where essentially this subject comes from?
So where the data is non-experimental in nature, then we use econometric models.
Where data is?
They're non-experimental in nature.
And what precisely you mean by non-experimental in nature?
So wherein we cannot classify the data into a control or experiment. Basically we have a set of data on which we want to test a theory. So that is a non-experimental data.
Could you just give any example?
So law of demand for that matter. So there is a general theory where we expect that the demand will fall for a good if the price is rising. So it is not experimental in nature. There are deviations, but it is universally true for any product that follow constant elasticity of demand. So then it is non-experimental in nature. So where data is non-experimental, then we use econometric models.
And where data is experimental, how do we go at them?
So we can use statistical models in those cases.
Okay. And what are those statistical models?
So for example, Pearson coefficient would be one thing wherein we are giving the rank, so it is experimental in nature.
Okay. Fair enough. So how econometrics is different from statistical methods and mathematical methods? What do you think? So would it suffice for an economist, because almost all the problems you can solve using statistical methods or application of those statistical methods on problems or problems related to economics. But why precisely we read or you try to have or build an econometric model is, when you do model building, first thing you must understand, चाहे कोई भी मॉडल बना रहे हो, it must have a proper theoretical content. जैसे आपने example दिया law of demand का, you can think of plethora of examples, relation between income and expenditure or inflation, unemployment. First of all, there is a proper theoretical background of any empirical problem. You have a theory which is called economic theory. So you have an economic theory, then you go for collection of data. That is, let's say, agar demand hai, so I'll go for collection of let's say any product. So I'll note the price and quantity demanded of that product. So I cannot have collection or data collection process prior to the theory that I have. सबसे पहला चीज जो entire इस discipline or इस subject में necessary है is to have an economic theory or have an economic model. And there are various examples like Phillips gave that there exists an inverse relationship between inflation and unemployment. Now this is a proper economic theory. How do I test it empirically? That's where econometrics comes into picture. So once I have this theory, once I know that, this has certain effect on this variable, that is, I have a universe, and that universe can be either entire world population at large or some regional population that we are concerned about. So a universe, mainly as far as statistical and econometric jargon goes, universe actually talks about list of all the possible outcomes that you can think of. हमारे पास एक यूनिवर्स है उस यूनिवर्स में हमने एक थियरी बिल्ड किया है. Let's say theory की law of demand है. No, कि whenever price of a commodity goes up, what is generally observed is quantity demanded if that commodity goes down. So this is a theory, this is a proper economic theory that I've built. Now how do I test it empirically? That's where econometric techniques will be used. So, after the economic theory is defined, I'll go for the collection of data. And before collection of data, what I do is I build a model first. Model in the sense that what precisely are we trying to find? Are we trying to employ a cause and effect relationship? That is, are we trying to say that whenever price of a commodity goes up, there's always a one-sided causation? That price of commodity going up, quantity demanded going down. Can it be viewed that, this has a bi-directional relationship? Or what kind of model precisely I build, it again depends on the researcher. And that's why you see entire econometrics, when I say that it is all about understanding how error terms behave, is precisely the same point that, depending from researcher to researcher, the kind of model that you have for a particular economic theory, it may differ from researcher to researcher, and precise difference lies in how you are assuming error terms behaving for your model. So first you have an economic theory, then you build an econometric model which precisely is a statement of the economic theory that you have had in an empirically testable form. So that becomes your econometric model. So when I write, let's say, a very common terminology of using in econometrics is that y is a function of, x, or all those x's are called your independent variables. Y is called your dependent variable. There are various other names that are given to them depending on, what you're reading or what you're trying to talk about. So we write those economic theory in an empirically testable content that is called your econometric model. So after you build your model, you must test it now. So उसके बाद आपका process आता है data collection process. इसमें आप कितने भी example लिख सकते हो. Let's say I want to test, whether people getting really good marks in GIP entrance, whether they perform really well in, semester end examination or examination that are conducted in Gokhale or at Gokhale Institute. Is there a correlation between them? Can I say for sure that those who do really well in entrances, they also do well in all the examination that they take at Gokhale Institute? So I go for data collection. Then so my next problem or next step is to collect those data. Now, अब यहीं पे this collection of data process में your primary fields or you can say primary questions and secondary questions differ. That is, there are variables for which already data has been collected. They are called secondary data. But there are so many other, variables for which you find no data available online or at any resource or at any sources. That's where your primary data collection comes. So data collection essentially is divided into two separate aspects, primary and secondary. We are not going to those aspects, but at least a cursory understanding will take you places. So अगर आपके पास data easily available है on various places में, you download those data, you filter, you apply, just sort your data so that you can use it for your own question. And then you go for estimation of those models. What precisely estimation of model is, कि पहले आपने ये मॉडल बनाया, उस पे आपने डेटा कलेक्ट किया, आपने उस सारे डेटा को यूज किया, एंड देन यू आर एस्टिमेटिंग. दैट इज estimation is about the parameters that are used in the model. And I'm sure that even if you have not had econometrics course, the most famous model that econometricians use is OLS, because that is considered as the classical model. जैसे हर एक डिसिप्लिन में हर एक सब्जेक्ट का एक क्लासिकल थॉट होता है, उसी तरह आपका क्लासिकल लीनियर रिग्रेशन मॉडल इज द यू कैन से starting point or basic starting point of building all other various econometric models that we have come to know so far. So estimation of the model is essentially estimation of those parameters, because you understand that data आपके पास क्या है? Data आपके पास वो है जो आपके variables हैं, और वो variables कौन decide करता है? Variables decide करता है researcher. So, in the same example, let's say, if a researcher is trying to find out whether a person or whether a student who is getting or who is doing really well in the entrances, he or she does really well in the examinations that are, conducted at Berkeley Institute itself. So essentially, what is the main variable or what are those two main variables between which you are trying to establish a cause and effect relationship? And apart from those two variables, all other variables which you think also have some kind of effect on the dependent variable, they are called control variables. So again, it depends on the researcher to researcher, how much research or what is his logic or what is his economic theory about a given particular topic. So estimation of the model is essentially about talking or finding out the value for those parameters which you use for all the explanatory variables in the model. And then comes the hypothesis part. You test the hypothesis. जो आपने imagine किया था, जो आपने assume किया था, जैसे law of demand है, या मैं इस केस में assume कर रहा हूँ कि हाँ, जिन्होंने अच्छा perform किया entrance test में, basically they should do good at Berkeley examinations as well. So I expect a positive relationship between these two variables, and this is precisely what we talk about testing those hypotheses. Whether the sign or the value that you thought for the parameters or for the coefficients which are attached to these explanatory variables, whether they turn out to be true or not. And that's why they are called hypotheses. Hypothesis is precisely an under-thesis. So you had a theory, you have data, now you're trying to prove or you're trying to establish the theory empirically using these data. And how do you establish your theory empirically is exactly testing the hypothesis that you had. Hypothesis. A thesis which has not yet become thesis, but after you estimate the model and everything comes out to be true, then it becomes your thesis. So that's the difference between hypothesis and thesis. That thesis is precisely what you intend to find out, and hypothesis is just the earlier step part. So going from hypothesis to thesis is precisely what is called the hypothesis testing part. So whatever you assume, whatever you thought, if that exactly you get, well and good. Or agar wo nahi hota, then you again go from the second step onward. आपके पास इकोनॉमिक थियरी तो है, अब कौन सा मॉडल यूज करना है, दैट इज अ ट्रायल एंड एरर एस्पेक्ट. whether I should use this particular variable or not, whether I should take this variable out, and that's where precisely the violations of assumptions come into picture. And I have not talked about anything at all. I'm just telling you how should we exactly understand this subject altogether. So essentially, econometrics, अगर आप layman की term में बात करो तो it basically means measurement in economics. What sort of measurement? And what sort of measurement is actually or precisely required in this discipline, economics? And the answer lies to this problem is that there are plethora of examples of bivariate relationships existing as far as economics is concerned. Price, quantity, income, consumption, inflation, unemployment, fiscal deficit, inflation, tax rates, economic growth. There are so many economic variables which exist in pairs. And econometrics is essentially concerned with the application of these, statistical and mathematical methods for the purpose of analyzing these economic data. To give certain empirical content to the economic theories that the researcher built, and then decide whether to keep this theory or refute the theory. And mind you, like now you are postgraduate students, if you go through any research papers on a similar topic, on a similar subject, what you essentially notice is that they differ either on the number of explanatory variables or on the model that they have. So suppose एक research question है जिसको दो researcher independently they are trying to find out. So in order to establish or in order to give an empirical content to the economic theory, which is that single research that is being conducted by two researchers independently, if the results that they obtain, like you had Phillips curve, फिर modified Phillips curve आया, फिर Milton Friedman आया, उन्होंने बोला कि ऐसा कुछ नहीं होता है, there is no long-run trade-off between inflation and employment. Then you had Lucas and Sargent coming in picture and then refuting the theory which was given by A.W. Phillips. Precisely, econometrics is application of these statistical and mathematical methods to the analysis of economic data with a defined purpose of giving an empirical content. And on that basis, whether to verify that or whether to keep that theory or refute that theory. So like जब Keynes ने बोला होगा कि there is some sort of relation between income and consumption. So this is the theory that he built. Now when he was writing, already there was some advancement in statistical methods because by then you had the most famous statistician R.A. Fisher by then, and there were good advancement in both the discipline, statistics and econometrics as well, because essentially econometrics came out of these fields. So the economic theory is that there exists an inverse relationship between income and consumption. Direct relationship between income and consumption. And the value of MPC, that is marginal propensity to consume, that value is precisely the coefficient or parameter attached to the income, which is the explanatory variable as far as Keynes' question goes. Because if you see how MPC is defined, it is change in consumption due to change in income. So what Keynes essentially said is that income acts as an independent variable, and whenever there's some changes in the income level of the consumer or income level of the society, there is a change in consumption. But whether that change in consumption is more than that of change in income is precisely what Keynes was or what Keynes went to find out. And that's why you say that NPC lies between 0 and 1 because, change in consumption cannot be greater than change in income unless you allow the concept of borrowing and lending in the economy. That is, a person can consume more than the changes in income that he or she has had. But leaving all those, rare and exceptional problems in part, so an econometric model will be built. Let's say I use an OLS model. Then I have the data, I test that model, I go for the hypothesis testing that I imagined a positive and a number or value of the coefficient attached to the income lying between 0 and 1. If I get that value, well and good, I establish my thesis. If I do not get that value, first of all, I go again for the trial and error method, whether I can improve upon the model. Can I include or exclude certain variables which I already have included in the model? So this entire process is built on trial and error method. That is, which model will be the best fit model for the data, for the economic data that you have in hand. So this entire discipline is just concerned about building an econometric model for an economic theory or economic content to establish it empirically. And how do we exactly establish empirically is by using those econometric methods. And that's where precisely the concepts which are taught in econometrics is very important. And it is precisely in these aspects. Why do you think that econometrics is a bit different from mathematical methods? Let me just present my screen now so that I'll start writing. Just give me a second. Yeah, can you all see the screen?
Yes, sir.
Yeah.
Yes, sir.
Okay. So, you see, when we talk about mathematical methods that are used in economics, you have to understand that mathematical relationships are those type of relationships which are deterministic in nature. So when I write y, is a function of x, where that function is signed. So whatever the limitation that this function has, that is called limitations on your domain. That is what kind of values you can actually put in x. But once that domain is defined, you get a precise and exact relationship between x and y. उसी तरह if you write y is equal to x square or under root x, log of x, any function, any mathematical function that you can think of. So when you have mathematical functions, those functions exhibit a deterministic relationship between variables. Why deterministic? Because an exact relationship holds. But how econometrics is different here is, because ultimately what we are doing is we are measuring. And no matter how accurate your measurement is, it can never be a deterministic relation. So if you had science in your 11th and 12th, those who are coming from science background, I'm sure that एक extremely difficult task होता है physics में prove करना कि gravity का value उतना ही जितना हम theoretically पढ़ते हैं. किसी का value कुछ आता है, किसी का value कुछ आता है, but एक range में अगर आता है, then your teacher gives you full marks. But is it possible that all of us get the same value, which is where people get caught when they when teacher assume that they have cheated? Because you cannot get same value of gravity, no matter how exact, how accurate your experiment has been. So whenever you have measurement in question, there is bound to be measurement error. And it is precisely this error which defines econometrics altogether. So say if anyone asks you, or if you're trying to learn this subject, you must understand that ultimately what you're doing is you're trying to have an estimate or guess about the distribution that error terms will have. Because once you control this error, then econometrics is all about establishing that deterministic relation. So it is precisely what kind of theoretical form, what kind of theoretical distribution form you want your errors to have. Do I want my error terms to behave in such a manner that they cancel out each other? Which is one of the very important assumptions as far as OLS or CLR is concerned. Am I facing an economic variable or data on economic variable where error terms are not normally distributed? Let's say error terms follow a log normal distribution. So what kind of exact or theoretical distribution that your error terms have exactly or precisely defines which kind of econometric model you should or should not use. So econometrics differs in this parameter from mathematical methods is that econometrics essentially is concerned about measurement, and since it is concerned about measurement, there are errors related to measurement, and since they are called errors of measurement or errors, we cannot have an exact guess about those errors. So ideally, a mathematical function we simply write y is a function of x. So in this case, x should be thought of as explanatory variable and y is explained variable, or x is independent variable. Why independent? Because this is exogenous. This does not depend on the model that we use. If we change this x, y is going to change. But if I'm talking about a mathematical functional relation like this, then I know that for each unique value of x, I'll get in unique value of y. Or instead of saying unique value of y, I should say you'll get an exact or deterministic value of y. It will not be that for a given value of x, so if I know that sine of x, and if you put x is equal to 45 degree, you know that y will have one particular value, sine of 45. It will not be sine of 45 plus minus something. So what are the essential building blocks that are required in econometrics? That's what we'll read now. So दो चीजें बहुत ही जरूरत है हमें यहाँ पे, और वो क्या है ये देखते हैं. First of all, where we are interested in establishing a cause and effect relationship. Cause and effect means if someone says that smoking causes lung cancer, so what I'm saying is that smoking, let's say, which is a variable x1, it definitely causes a variable which let me call as y. So what I'm essentially saying is that x1 has a one directional effect. So x1 is cause, that is smoking is cause of lung cancer. This is not true. Anyway, So when we have to establish a cause and effect relationship, that's where we use econometrics. Now either it will have a unidirectional position, which is what we are mostly taught, or we can have bidirectional position where we use the concepts of simultaneous equations. Like price and quantity. If you say equilibrium price, they are decided by interaction of both the supply and demand. So it is not something that you keep your prices fixed and then determine quantity. It is not like that. Whenever you have change in either of the graph, you have change in both equilibrium price and equilibrium quantity. So what it says that price and quantity are simultaneously determined. And then you also have certain cases where you have bidirectional position, like crime and police. जिस जगह पे जितना ज्यादा क्राइम रेट होगा उतना ही ज्यादा पुलिसिंग की जरूरत होगी, ये एक रिलेशन है. एक और रिलेशन है कि जहां पे बहुत ज्यादा पुलिस की रिक्वायरमेंट है, इट ऑटोमेटिकली मीन्स दैट क्राइम रेट इज ऑल्सो वेरी हाई इन दैट रीजन. So that is called bidirectional causation, which we'll read once we go ahead in the course. But precisely where we have to establish a cause and effect relationship is exactly where we use econometrics. अब terminologies क्या क्या है, कैसे हम इसको लिखते हैं, कैसे समझते हैं? So econometrics में we are mainly concerned with two set of variables. First set of variable is called your explain or explanatory variable, or independent variable, or regressors, or regresses. And the second set of variable they are called either as explained variables, or dependent variables, or regressants. So essentially, we need to understand about these variables. So the very name suggests explanatory variables. What it means is that these are those variables which determine the movement in the variable about which we are trying to establish anything. And they are usually denoted in the econometrics textbook by X. Again, I'm saying usually denoted. आपको जो पसंद है वैसा आप use कीजिए. Z use कीजिए, W use कीजिए. No one will have a question. And then you have explained variables. The explained variables are those variables whose movements are constrained by the movements that are witnessed or that are to be seen in these variables, explanatory variables. So on the one hand, you have those variables which explain certain phenomena, which I can say that it causes certain phenomena to happen. And explained variable or dependent variables are those variables which depend on these variables. And they are usually denoted by Y. So अभी हमने क्या देखा that econometrics is essentially application of statistical and mathematical methods to the analysis of economic data with the purpose of giving an empirical content. So it automatically means that before I have a model in place, I must have an economic theory behind that. So if I'm saying that there's some sort of relationship between price and quantity, I am establishing an economic theory which is commonly referred to as law of demand. Now, how do I test it empirically? That's where econometric models will come. So first of all, I know that before talking about econometrics or econometric techniques, I must have an economic theory in mind. And that economic theory, since I'm measuring about that or measuring that economic theory or giving an empirical content to that theory, it must contain an error. So if I'm writing that y, that is dependent variable, is a function of x, you must understand that by x I do not mean only single variable, it may x1, x2, x3, jitna bhi aap soch sakte ho. And if I just stop here, this will not be an econometric model. This is a precise relationship and it's called a mathematical model. Then what I do is, I add a new term which I denote by UI. And this is precisely what is called as errors. And this is precisely the equation of model, econometric model that we write or that we have for any set of data in our hand. So what it says is that y is a function of x, no doubt, but then there's also a stochastic term attached to this relation. And if you just hide this UI for now, then it is precisely a mathematical relationship. But since this UI enters into picture, that's why it becomes probabilistic in nature. And since there is an element of probability that is attached to it, that's why we are talking about joint distribution of these variables y and x. That is, ultimately we are concerned about the conditional joint probabilities of explained and explanatory variables is all what an econometric model talks about. And why I'm saying conditional, I'll make this term clearer as we go ahead. But for now, you understand that since there's an additional error term entering into picture, which brings an element of randomness or uncertainty or stochasticity, that's why this no longer is an exact relationship. This becomes a sort of, or you can think of that, this can be thought of as sum of two individual components. This f of x part can be thought of as deterministic part, and this ui part can be thought of as stochastic part. And it is precisely what econometrics is all about. What kind of theoretical distribution form you are trying to attach to this UI? How you want your UI to behave? Whether you want your error terms to behave normally, or they should be normally distributed, or they are non-normally distributed. If they are non-normally distributed, what kind of econometric methods should I use so that I can have an estimate of relationship between y and x? Because ultimately what we are doing is we are guessing. Which method gives me the best guess possible is all about selecting the best fit econometric model. Guys, am I clear till now? I have not taught anything. I'm just telling you all the basic things. Is there any problem as of now?
No, sir. All clear.
No, sir.
Am I going too fast, too slow?
Sir, I've got a question, sir.
Yeah.
Sir, you said you explained about exogenous variable and error terms. But sir, if we know both the terms, wouldn't it be the exact answer? Because we are guessing in the dark, basically. As you said, there is no precise. But this seems to suggest that we know the precise answer.
But how can you know your error term there?
So we'll calculate.
Error term is precisely what is not known.
Okay, sir.
And that's why they are called errors. अब जैसे आप मान लो किसी का हाइट मुझे मेजर करना है, no matter how accurate your scale is, there will be a measurement error all the time, and which you don't know. So error term is precisely what we don't know as a researcher. What I know, and which is called studying from literature review, which is what is taught in research methodology course. That how do you exactly go for literature review will determine your excess. But error term is unknown. I don't precisely know what form of error term is, and that's why since they bring this element of randomness, we assume certain probabilistic distribution for these error terms. So we either assume error terms are normally distributed or non-normally distributed. So अगर normally distributed है तो आपके results में कैसे फर्क आएगा, non-normally distributed है तो कैसे फर्क आएगा. But this error term is not known. Is that clear?
Yes, sir. Just I would like to ask for an example. Just now I checked my phone and it shows the temperature readings. So, sir, it's like say 38 degrees is the approximate temperature plus or minus 0.7 degrees. So, can you say that 0.7 degrees is the estimation of error, sir?
That will be the estimation of error, not the error itself.
Okay, sir.
अब आप दोबारा अगर कभी आप उसको मेजर करोगे हो सकता है 30 प्लस माइनस 0.2 आ जाए.
Okay, sir.
और 0.3 आए, 0.1 आए, 0.9 आए. Do you understand what I'm talking about? So
Yes,
that
sir. Yes,
error
sir.
term is not fixed.
Okay, sir.
It is random, and that's why it is called as stochastic.
Okay, sir.
Chalega everyone? Shall I move ahead?
Yes, sir.
Okay, guys. Shall I move ahead now?
Yes, sir.
Okay. जहाँ पे भी आपको लगे कि मैं थोड़ा फास्ट जा रहा हूँ, please stop me. Okay, all right. So after we have understood what these explanatory and explained variables are, next step is how do we exactly write an econometric model? So अभी हमने उसको implicit functional form में देखा that we write y is a function of x plus a random error term ui. And since I'm writing random error term ui, I must also write yi over here. अब देखो ये चीजें कैसे यहां से आगे बढ़ती हैं. Now, how exactly do we visualize these things? इसको देखते हैं पहले. So क्या है हमारे पास? एक यूनिवर्स है. इस यूनिवर्स में मेरे दोनों वेरिएबल ऐसे खड़े हैं, y है, x है, x1, x2, x3, x4, x5, x6. So ultimately the purpose of statistics is to quantify any variable. That's why we use statistics. Otherwise, what is the use? So these are the variables which are floating independently in the universe. यहाँ पे एक रिसर्चर बैठा हुआ है, कुछ काम नहीं है उसको, and he's trying to find a pattern or he's trying to find some sort of relationship between these 5 or 6 variables that he notices in this universe. Now this can be anything. This can be relationship between number of years of education and wage rate earned by an individual. So let's say x1 को मैं मानता हूं नंबर ऑफ इयर्स ऑफ एजुकेशन और y मेरा वेज रेट है. मैं एक्चुअली प्रिसाइजली फाइंड करना चाहता हूं कि वेज रेट जो एक इंडिविजुअल अर्न करता है वो किन किन फैक्टर्स पे डिपेंड करता होगा. तो मैं एक यूनिवर्स ले लिया, लेट्स से पूना के पॉपुलेशन का और लेट्स से इंडिया के पॉपुलेशन को मैंने यूनिवर्स मान लिया कि इंडिया में वेज रेट्स कैसे डिटरमाइन होते हैं. हाउ एग्जैक्टली एन इंडिविजुअल अर्न्स द वेज ही और शी अर्न्स. ये मेरे दिमाग में क्वेश्चन आया और मैं चला गया बुक्स पढ़ने के लिए. बहुत सारे रिसर्च पेपर पढ़े, बहुत लोगों का बहुत चीज कहना है, मैं सबको टेस्ट नहीं कर पाऊंगा. एंड प्रिसाइजली आर all those explanatory variables which are floating in the universe which you identify and filtered out from the list of literature that you have read yourself, which is called a literature review. So let's say मैंने पूरा literature पढ़ लिया wage rate और determinants of wage rate के बारे में, then I come to think of two main variable which has a certain effect on wage rate earned by an individual. So the first among them is number of years of education, and the second is experience. So now, let's say Neil उठ के आता है and then he says कि sir experience और number of years of education के अलावा I think gender बहुत matter करेगा. I think the person from which region he has come from, whether he has come from east, south, north, west, it also matters a lot, sir. What kind of expertise he or she has also matters. So these are, again, that's what I'm saying, that number of experimental variables that you are having in a model depends from researcher to researcher. But my research says that only these are the two variables which I should explicitly include in the model. And I'm not saying that these are the only two variables which have a certain effect on the Y. There are other variables as well, but explicitly such variables need not be included in the model. So what I'm precisely saying here is that if I'm denoting wage rate to be Y, then Y is a function of X1 and X2. I'm not saying what kind of functional form, plus a random error term UI. I should also write X1I, X2I over here. So all those variables which are explicitly included in the deterministic component of the model, they are called as explanatory variables.
Sir?
Yeah.
If you have taken X1 and X2 because the researcher wants to determine the relationship, how does Y change when only X1 and X2 change, not other variables? He's deciding that.
Correct.
Thank you.
So rest all the variables. Yeah.
So basically we can say that these exercises are very subjective thing for every company, no? Like which exercise one should take or which company takes.
Correct.
Okay.
Yeah. That's what I'm saying, that these exercises depend on the research conducted by the researcher. तो हो सकता है कल कोई उठ के आता है बोलता है सर एक्सपीरियंस भी मैटर नहीं करता, forget about it, I only run or I only try to find out a cause and effect relation between number of years of education and wage rate. कोई आगे बोलता नहीं, apart from these two variables, 3 other variables are required. So in total, let's say it takes till X5. So 5 explanatory variables are there. So these X's depend from researcher to researcher. And that is where the importance of literature review is so important, becomes so paramount. So Y, which is wage rate earned by an individual, is a function of number of years of education and experience plus a random error term. So मेरा कैसा जाएगा, ये तो मैंने मॉडल बना दिया, और मैं क्या एक्सपेक्ट कर रहा हूँ कि आई थिंक यार जितना ज्यादा इयर्स ऑफ एजुकेशन होगा, जितना ज्यादा डिग्री एक बंदे के पास होगा, उतना ज्यादा he or she will earn better wage. So I expect a positive relation between X1 and Y. Similarly, I also think that with years of experience, the wage rate earned by an individual should go up. So I also expect a positive relation between, though there are limitations in this assumption, but just for the time being, just assume that with number of years of experience, with increase in years of experience, wage rate earned by an individual should go up. So I also expect a positive relation between X2 and Y. So once I estimate the model, the coefficients which are attached to these X1 and X2, because they are mathematical functions, So those coefficient must be positive if my model is properly or correctly estimated. So I am done with my econometric model. Then the next step is I'll go and collect data. So let's say I have 100 individuals. N is equal to 100, which starts from 1 and goes till 100. So मैंने पहला इंडिविजुअल लिया, उसका ईयर ऑफ एजुकेशन नोट किया, एक्सपीरियंस नोट किया, उसका वेज रेट मेरे पास है. सेकेंड इंडिविजुअल ईयर्स ऑफ एजुकेशन एक्सपीरियंस, उसका वेज मेरे पास है. इस तरह करके आई कलेक्ट 100 such observations, and here observations are nothing but individuals in the question. So I collect 100 such observations on these individuals and data on 3 variables, out of which 2 are these explanatory variables, number of years of education and experience, and 1 is your wage rate earned by an individual. So इस तरह करके मेरा पूरा एक डेटा कलेक्शन हो जाएगा. I am sure that now you understand that I'll have Y1, Y2 से लेके Y100 observations on Y. Similarly, I'll have X11, X12, X13 से लेके X100 on X1, and I'll also have 100 such observations on X2. And this is nothing but what is called your data collection process. So now I have these data on these variables. और अगर एक एग्जैक्ट मैथमेटिकल रिलेशनशिप होता तब तो इकोनोमेट्रिक मेथड्स की जरूरत ही नहीं है. Because I have the data on this variable, I have the data on this variable. Let us say I say that 0.7 times this vector plus 0.9 times this vector exactly is equal to the wage rate earned by the individuals. Then there is no need for econometrics. But I know that apart from these coefficients, I also have error term associated with each of those 100 observations. And as such, I cannot ignore this error term. And that's why I assume certain things about these error terms. I assume how should they behave. And it is precisely the assumption of error terms which differ from model to model. एक बहुत ही आपने सुना होगा जिन्होंने भी इकोनोमेट्रिक्स और स्टैटिस्टिक्स आपने पढ़ा है, तो there are these terms called heteroscedasticity, autocorrelation, non-normally distributed error terms. These are precisely the assumptions that we require, or violations हैं तो ऐसे, but there are certain set of assumptions that we require for our error terms to behave in a specific manner. Because it is precisely the assumptions related to error or the forms of error distribution in the model which will determine whether my model is best fit or not. And I remember someone saying that econometrics is all about minimizing those error terms. That is just one aspect of econometrics. And that is just one aspect which is used as far as ordinary least square method is concerned. तो अब मैं इसको इकोनोमेट्रिक टर्म में कैसे देखता हूं, कैसे लिखूंगा इसको. तो एक इक्वेशन के फॉर्म में इफ आई वांट टू राइट इट, सो हाउ डू आई राइट इट? y is a function of x1 and x2. But what type of function do am I expecting? I am not saying anything like that. And that's where I have the first assumption of CLRM in place. CLRM stands for Classical Linear Regression Model. And guys, let me tell you that this is one of the most frequently asked questions. What is the difference between regression versus correlation? I leave it to you to find out, and you can read in textbook or you can go through the lecture that is on the channel. It will be, I think, lecture number 2 or lecture number 3. Please go through this regression versus correlation. The reason I'm not telling you here is so that you read it yourself and just build knowledge around this, because this is one of the most frequently asked questions. Regression क्या है? Correlation क्या है? So I'm skipping this portion. Request you to learn this or request you to go through this yourself. If at all you find it difficulty, I'm here to help you out. But as far as videos are concerned, you can go through that video lecture, or books. You can go through any book where you can find a good difference between regression and correlation. So this CLRM stands for classical linear regression model. So what we say is that our model, as far as classical model is concerned, it must be linear. And linear in what? Do I want this model to be linear in variables? That is, do I want my model to only contain the explanatory variables of the power 1? That's where the answer is that I want my model to be linear in parameters. The first thing that you should understand is that the CLRM model talks about the model which is linear in parameters. Now you must ask me what exactly is parameters. That's where the first assumption is, so I write my model as y beta 1 times x1. This is the common terminology. That's why I am also writing beta 1. You can write eta 1, gamma 1, no one stops you. Beta 1 x1, beta 2 x2. So linear in parameters means what? This parameter which enters the equation, it must be linear. It cannot be something like this. It cannot be something like this. It cannot be something like this. The parameter entering the equation must be linear, and which is precisely this L stands for CLRM, in the acronym of CLRM, that your model is linear in parameter. And what is this parameter? These parameters are the coefficients which are attached to the explanatory variable that I have included in the model. And linear function कैसे लिखते हैं? If you're thinking that mx plus c, और आप number of variables बढ़ाते जाओ, you write ax plus, let's say W, ax plus by plus cz, where I have these three components. So what is generally noticed is, if you actually think this x, y, z as the explanatory variables, these a, b and c are the parameters, and what you notice is that these parameters are attached to the respective variables and they are added. And this is precisely called as linear combination, which is a very important concept as far as linear algebra is concerned. And I'm sure once you go through these appendices given at the end of any good econometrics textbook, you'll find that linear combination of vectors are very, very important as far as understanding this equation is concerned. Otherwise, it will be extremely uneasy for you to visualize what you have written over here. So what y essentially is a linear combination of this x1 and x2. Linear combination exactly kya hai? I'll just tell you in very brief. You see, if I have this x1 explanatory variable, x2 explanatory variable, let us say you have three individuals. So this x1 explanatory variable is a column vector consisting of three elements. अगेन x2 में मेरे आपके पास 3 इंडिविजुअल पे डेटा है, सो x2 guys 1 second. Sorry. So x1, x2, these are the column vector consisting of 3 number of elements. And I know that in the Euclidean space, I can represent these x1 and x2 by a point or by a vector. So just for a simple case, let us assume that I'm talking about plane which or surface which looks like this, and this is my x1, this is my x2. So origin से मैं x1 को तो denote कर सकता हूँ by this vector, x2 को भी denote कर सकता हूँ by this vector. This is one of the very important points as far as Euclidean space is concerned. तो लीनियर कॉम्बिनेशन मतलब क्या हुआ, इसका लॉजिक आप देखिए. लीनियर कॉम्बिनेशन मैंने कैसे डिफाइन किया यहाँ पे डियर. I wrote beta1 times x1 plus beta2 times x2, and then I said that this beta1 and beta2 should not be non-linear. It must have a power of 1. So this beta1 and beta2 acts like they are a parametric constant. Why I'm saying that parametric constant is, though they are constant, but they also change depending on the model, depending on the data at your hand. But once you have the data, they are fixed for that particular data. That's what they're called as parametric constants. They are parameters which behave as constants, but they are not constant the way we understand constant as a term. So linear combination में हमने क्या देखा, मेरे पास दो वेक्टर था x1 and x2. उस वेक्टर को मैंने एक कोएफिशिएंट से मल्टीप्लाई कर दिया, एक स्केलर मल्टीप्लाई किया मैंने उसको. So let's say this x1, let's say I take half of this x1. So beta 1 for me here is half. So इसका मतलब क्या हुआ, ये मेरे पास वेक्टर है, इसका मैं half x1 लिया, means क्या हुआ, I am at this point now because I have just reduced this vector by half. So now this is my new variable. So half of x1, let's say plus 3/4 of x2. So beta 2 is 3/4. It means x2 का आपने 3/4 लिया. Let's say this is the 3/4 point. So now your new vector is this and this, which is nothing but some or certain part of the original vectors that you have. And then what I've done, I've simply added them. Add them. So once I added them, I definitely should reach a certain point. Let's say hypothetically, let me say I reached this point. Let me call this vector, let's say इसको मैं A मानता हूँ, इसको B मानता हूँ, इसको C मानता हूँ. So C क्या है exactly? C can be thought of as half of A plus 3/4 of B. And इस तरह, using these two vectors, changing the value of these coefficients, I can totally span this entire space, which is called as vector span. That is, you change this value 1/2 को आप -1/2 करो तो ये वेक्टर इस डायरेक्शन में चला जाएगा. You either, when you multiply or divide a vector, you are shrinking the size of the vector depending on the sign, and then you're adding. It means linear combination of vectors is defined precisely by two important steps. First is called your scalar multiplication, and second is called your addition of those vectors. So इसका मतलब क्या हुआ कि अगर मेरे पास सिर्फ ये दो वेक्टर हैं, इसका एक कंडीशन है which I'll mention later. If I have these two vectors, using different combination of these two vectors, I can totally span this entire space. That is, using different combination of this vector, I can reach here, 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 I can reach this entire space. And एक और चीज जो आपको नोटिस करना है कि all these linear combination of vectors using A and B, they also lie in that same space where these two vectors are. So linear combination means आपके पास एक वेक्टर है, उसका आपने एक सर्टेन पोर्शन निकाल लिया उससे, दूसरा वेक्टर उससे भी सर्टेन कंपोनेंट आपने निकाल लिया, उन दोनों को ऐड कर दिया, एंड देन यू आर रीचिंग सर्टेन पॉइंट. एंड इस तरह करके वेरिंग द वेरियस values of these parameters, you can, if you are talking about two-dimensional vector, you will be able to span the entire two-dimensional space, provided you meet or you fulfill one important condition, which is called as that these vectors must be linearly independent. What do I exactly mean by this? Let us understand this point. ये मेरा A है, ये मेरा B है. As long as they are linearly independent means they are not collinear. That is, there is some sort of cos theta between them, or angle between two vectors. As long as, so आप यहाँ पे ये सोचो, अगर ये A है और ये आपका B है, if these two vectors are collinear, there is no linear combination of these two vectors जहां पे आप दूसरे कहीं और पॉइंट स्पेस में पहुंच पाओगे. You cannot do that. I'm sure आप जब बच्चे होंगे तो one of the very famous drawing that we draw is हमारे पास एक compass होता है. We fix that compass at one place and then we rotate that compass and it somewhere goes like this. Then you draw certain curves like that. Why is that possible? Because the compass and the variable point, it has got certain angle between them. If you reduce this angle to 0, you will not be able to span this space. This is precisely this linear combination is all about. So as long as these two vectors are not collinear, that is, as long as they are linearly independent, I can think about linear combination of these two vectors A and B, and a linear combination of these two vectors A and B will be this entire space. तो ये रही बात linear combination की, और मैं सब बात और linear combination की बात हमने की भी क्यों? That's where what I had written was beta 1 x1 plus beta 2 x2. So as of now, I have not included the error term. What I am saying is that if there was no error term, then exact and precise value of y can be obtained by having a fixed value for this beta 1 and beta 2. And since I have the variables on x1 and x2, so beta 1 and beta 2 का सिर्फ value मुझे निकालना है, then I can get to this y precisely. There is no approximate guess. And how do I get this? This is a linear combination of x1 and x2. But ये एक mathematical relation तो है नहीं, ये एक stochastic relation है, और वो stochasticity क्यों आता है? Because I have this error term. And now you understand and precisely I have discussed assumption 1 with you now, which is called linear in parameters. क्या है?
I have a question.
Yeah.
Sir, if there is an interaction term, does the linearity assumption still hold?
Interaction term between what term?
Between the variables, sir. For example, like two variables x1 and x2, if there is an interaction term, like you're adding them, multiplying them, anything, so the coefficients get added or the coefficients are multiplied or divided. So does the linearity assumption still hold?
It has to hold. It has to hold. Otherwise, your OLS will not, or you will not be able to estimate your model using OLS.
Okay, sir.
Because linearity is in this. Linear combination हमने कैसे देखा? Linear combination.
Basically, I had this doubt because, say, for example, if I'm dividing beta 1 by beta 2, say there are three variables, okay? Then if I'm able to express my, like, this interaction term ka value in terms of square of another variable's beta, so then it does not necessarily become like, linear in parameter anymore. So that is why I was asking this question. So basically, if I'm dividing beta 2 by beta 1 and it can be represented in a form of like, square of some other beta 3, so does the linearity assumption still hold?
See, that's where my answer lies. That linearity is only for this parameter. And if you are dividing beta 1 by beta 2 or any variable, as long as the parameters are non-linear, you will not be able to run an OLS. No matter how many modifications you have.
Sorry?
Yeah, no matter how many modifications you make in the model, if your parameter is non-linear, you're not running an OLS. You will not be able to estimate a linear model. In fact, you'll have to go through what is called as non-linear estimations.
Okay, sir.
Yeah. So OLS use करने के लिए या जो CLRM का जो फर्स्ट और सबसे फंडामेंटल assumption है यही है कि आपका पैरामीटर लीनियर होना चाहिए और ऐसा नहीं कि आपको सारे मॉडल इस फॉर्म में आपको लिखना है हो सकता है बहुत सारे मॉडल जो बहुत सारे इकोनॉमिक फॉर्म जैसे आप जिसमें कॉक डगलस यूज करते हैं we simply write k to the power alpha l to the 1 minus alpha and in that case if I have to run or if I have to estimate this Cobb-Douglas production function using OLS, I have to modify, I have to transform this function in such a way that these parameters alpha and 1 minus alpha enters linearly in the model. And that's why in order to estimate a Cobb-Douglas production function, what we do is we take the logarithmic transformation of the original function. So in that case, we write log of y is equal to alpha times log of k plus 1 minus alpha times log of 1 minus log of l. And then alpha and 1 minus alpha being the parameters, they enter linearly. So depending on what kind of transformations you're having, as long as that transformation renders a linear parameter, you're good to go. And if that transformation does not render you a linear parameter, you cannot use the linear models used in econometrics. उसके लिए आपको non-linear models use करने होंगे. Is that clear?
Yes, sir.
So जो linearity parameter का जो assumption है, उसका simple आपको कैसे याद रखना है कि ultimately I'm talking about the linear combination. And precisely, you know why it happens is, अभी हमने just देखा जो linear combination of vectors है, this lies in the same space. If it was non-linear parameters, that is, if let's say beta 1 was not beta 1 square or under root of beta 1, then this linear combination of vectors itself is not possible. Because ultimately linear combination is defined by two important operations, that is scalar multiplication. The moment you have non-linear parameters, you do not, or you're not having the first part of operation, that is scalar multiplication of the vectors. And इसका best possible visualization आप ऐसे सोच सकते हो. Suppose let's say the study table that you are reading on, this is the study table, just forgive me for the drawing. Imagine ये study table है. A study table is a very solid surface. Very solid surface means what? If I define a unit vector in x direction, a unit vector in y direction, then a proper, and these I and j, they are, since they are unit vectors, they are orthogonal to each other. That's why they are completely independent of each other. So with any combination of this xi hat plus yj hat, I can go to any point on this table. And you must understand, since I'm talking about linear combination, then I'm reaching on the same surface on which these two vectors lie. अगर ये non-linear होता, then I might have let's say study table से आप उठ के, suppose this is a point which is outside the, or which is, let's say outside of this surface of the table on which you're studying. This is not linear combination. So linear combination, अब इसको आप इकोनोमेट्रिक के जार्गन में अगर इस्टेब्लिश करने का सोचो तो हमने क्या देखा था, ये यूनिवर्स है मेरा, ये मेरे पे y वेक्टर भी, x1 भी, x2 भी, x3 सारे बहुत सारे एक्सपेक्टेड वेरिएबल्स है. अगर मैं सिंपल लिखता हूं y is a linear combination of x1 and x2, it means what, that using certain combination of x1 and x2 I can reach to the point y, where y is. Had it been a mathematical relationship, well and good, but do I reach at the exact point of y? No. Because ultimately, what happens in econometrics is that y lies outside the plane or outside the space spanned by the linear combination of the explanatory vectors. So suppose original y ये है, ये point, which is not lying on the table. अगर ये table पे रहता तो error term तो होते ही नहीं यहाँ पे. Because by finding the unique value of beta 1 and beta 2, I can reach to this exact point of y which lies in the space itself. But let's say this y lies outside of this space. And that is where estimation, and that's why we call it estimation. Now, if you change these x1 and x2 and x4, जो भी आपने explanatory variables है, researcher change कर देता है, then you will have a different combination of x1, x2, which will take you to y. So what it shows is, or what it tells you is, that y is conditioned on the explanatory variable x that we have taken. If you change this explanatory variable, your y also is bound to change. Or the distribution that y has is going to change. That's why it is also called sometimes as conditional regression. And if you have some statistical background, in probability we write conditional regression or conditional form as expectation. So we write expected value of y conditioned on the set of x that we have taken. So जो y हम actually लिखते हैं यहाँ पे, that is actually this. If you change these value of x, your y is going to change. Which we'll discuss, but you have to understand this. So linear combination means क्या हुआ, या linear का मतलब क्या हुआ, जो assumption अपना पहला है, that my model is linear in parameters. And again, I'm telling you that it is not necessary that your original economic model is linear itself. You have to transform that model into linear term. And if by suitable transformation you are able to transform it into linear parameter model, then you are good to go, at least as far as the first assumption is concerned. So this form of writing econometric model like beta 1 x1 plus beta 2 x2 plus a random error term is that this part, which is called as deterministic part or non-stochastic part, is the linear combination of these two vectors or these two explanatory variables that you have included in the model. You go on including the number of explanatory variables, as many combination of vectors you'll have. So let's say if I have k number of such explanatory variables, which is how generally textbooks write. So how do I write it as y is beta 1 x1 plus beta 2 x2 plus beta 3 x3 से लेके beta k xk plus a random term u. I have not written any subscript, just it's a single equation. So what it says is that y is a linear combination of these k number of explanatory variables. And if this error term was not here, then this is a precise mathematical relationship. This is nothing but system of linear equations in that form. But since this error term is there, that's where econometric methods are so useful. So the first assumption is that these parameters which enter in the equation must be linear, and also the error term which enters the equation must be additive. Why exactly is it additive in nature? We'll come to understand this as we go ahead in the next for the understanding next assumption. But as far as the time is concerned, just think that this error term must not enter the model multiplicatively. It must be additive. So error term enters the equation. Additive in nature means apart from those linear combination of x's plus this error component, which is what once we go ahead, it signifies that error terms and these linear combination of x's, they are orthogonal to each other, and that's why I'm able to write y separately as sum of these two components. अगर ये orthogonal नहीं होते, if error term enters multiplicatively, then your assumption of linearity goes for a toss. So the first assumption of CLRM, which is linearity in parameters, it refers to the case of parameters entering the equation linearly along with error terms being additive in nature. Additive means it enters the equation in an additive fashion. It is just added to the equation which tells you the linear combination of x's for y. So as long as you're transforming a non-linear model into a linear model and these two conditions are satisfied, you are good to go as far as the method of OLS is concerned. Or econometric methods of classical linear regression model is concerned. बहुत ही सिंपल लॉजिक है इसका कि आपके पास ये सारा पॉपुलेशन है, डिपेंडिंग ऑन योर रिसर्च आपने उन एक्सप्लेनेटरी वेरिएबल्स को आइडेंटिफाई किया जो कि एक्सप्लेन करते हैं आपके डिपेंडेंट वेरिएबल्स को. And since I'm talking about an element of uncertainty, that is stochasticity, I'm talking about joint distribution of y with these x's. I'm sure आपने joint distribution, joint probability distribution पढ़ा होगा, joint PDF, joint CDF, and so on and so forth. So ultimately, regression, if you go a little bit higher in notation, regression is nothing but conditional joint distribution of y with x's. Because ultimately, if I have k number of such explanatory variables, what I'm trying to talk about here is the joint probability distribution of y with all these explanatory variables. And why precisely probability distribution in the first place is because I have an element of stochasticity in my model. That brings an element of randomness. It disturbs an otherwise very stable relationship. So if this error term was not there, this is a stable relationship, but inclusion of this error term disturbs this. And that's why it is also called as disturbances or disturbance term. Is this clear, everyone?
Yes, sir.
Is the first assumption of linearity in parameters clear?
Yes, sir.
Yes, sir.
Okay, I'll just take the next assumption in brief and then I wind up the lecture. अब इसी assumption से related दूसरा assumption है. अभी हमने क्या देखा? Linear combination कब possible है? Linear combinations are only possible if the explanatory variables or the vectors are linearly independent. Now someone should ask me, what exactly so you mean by linearly independent? So linearly independent means क्या हुआ? Linearly independent means हुआ कि if I have two variables, let's say x1 and x2, if they are linearly independent, it means that the correlation between them is zero. And mind you, I am using the word correlation because correlation is a term which is used to signify the extent of linear associationship between two variables. I'll repeat it here. Correlation, you need not write to all this, refers to the strength or degree of linear so correlation only tells you the linear relationship amongst variables. So linearly independent means what? कि linearly x1 और x2 आपस में एक साथ वेरी नहीं कर रहे. हो सकता है x1 is a function of x2 square. x1 might be a function of under root of x2. But there is no such relation of x1 or between x1 and x2 where I can write x1 is a times x2 plus let's say b. So if two vectors are linearly independent, it means correlation coefficient between those vectors are zero. And that's where the second assumption comes into picture, which is called as assumptions of no multicollinearity. बहुत related है आपस में. Multicollinearity. Collinear means what? Two vectors हैं, इन दोनों के बीच में कुछ relation है. It means what? There is some angle. I'm sure that आपने पढ़ा होगा cos theta also. This theta is an angle between two vectors. A little bit knowledge of trigonometry will tell you this. So the assumption of multicollinearity क्या बोलता है आपको कि अगर x1, x2, x3 से लेके xk number of explanative variables है आपके मॉडल में, and if you have included them explicitly, again I'm using this term explicitly. Why I'm using this term explicitly is कि suppose एक researcher ने सिर्फ दो ही explanative variable include किया अपने मॉडल में, it means that all other variables, हो सकता है जो वो ignore कर गया, हो सकता है जो उसकी study limited हो, all other variables he's including them in the error term. So as long as you are including the number of explanative variables explicitly in the model, what this assumption tells you is that all these explanative variables must be linearly independent of each other. That is, they should not be collinear. और इसका एक बहुत अच्छा लॉजिक है. लॉजिक ये है कि अगर आपने इतने नंबर ऑफ एक्सप्लेनेटिव वेरिएबल्स यूज किए, इसका मतलब क्या कि आपको लगता है ऐसा कि हर ये जितने k नंबर ऑफ एक्सप्लेनेटिव वेरिएबल्स हैं, each of those k number of explanative variables has got some amount of significant impact on the movement of y. And all these k number of explanative variables are individually necessarily significant. That's why you're including them in the model explicitly. But अगर उनमें से कोई भी दो आपस में कोलिनियर हो गए, suppose x1 and x2 are collinear. Collinear means what? Collinear means they lie on the same line. It means I can obtain one vector if I have knowledge on the other vector. It means these two vectors need not necessarily be included separately in the model. I can just do away with any one of the variables. So this is the assumption in CLRM which is called as assumption of no perfect multi-collinearity. What this assumption tells you is that the variables which are including in the model explicitly, they must be non-collinear. They must not lie on the same line, because if they lie on the same line, I am not talking about any angle between them, and if I'm not talking about any angle between them, it means I can just do away with one of the variables. So the assumption of multicollinearity, once we read this assumption in matrices notation, it is also called as assumption of full column rank, which we'll talk about in next class. I'll stop here and just try going through the assumptions chapter from Woolrich or William Green if you like to read. Start from matrices method, which will. So matrices method ऐसा कुछ नहीं कि बहुत ही skyrocket चीज है. Matrices method helps you visualize the equation that you write when you have data, or when you see ultimately if I just write y is a function of x1, x2, and xk, it is just a single equation. So it is not very easy for us to visualize from our naked eye that how exactly this entire process goes on. Because ultimately when we go for the data collection, we find ourselves, or we present ourselves the data in the form of a matrix, where rows denotes the number of observations and columns denote the number of variables in the model. This is how you collect data. But when I write them just in a single equation form, it is absolutely very difficult for me to visualize exactly what is going on. So I'll stop here. In the next class, probably I'll not meet on this Thursday, but I'll inform you, or coordinators will inform you about that. So when I start, or when we meet for the next class, it's an earnest request to go through at least the assumptions of CLRM portion. Because guys, it is the assumptions जहाँ पे बहुत सारे डाउट्स होते हैं, और वो आपका अगर assumptions एक बार क्लियर हो जाएगा, then in order to interpret, or in order to remove the violations which are related to assumptions of CLRM, you'll find no difficulty. So we'll devote good amount of time on understanding these assumptions. Once we understand these assumptions, then rest of the things can be moved in a very easy and sophisticated manner. So I stop here. Is there any question that you'd like to ask?
Sir?
Yeah.
Sir, so you have used a sentence, no perfect multicollinearity. So whether it means like there could be some extent of collinearity between variable, or that would be acceptable?
Come again, dear?
So, sir, a sentence you have used, no perfect multicollinearity in this assumption.
Right.
So, is there any extent till there we can accept the multicollinearity between the variable?
See, multicollinearity, which I'll discuss, is more of a problem of degrees. See, why I'm saying perfect multicollinearity is that perfect multicollinearity talks about the vectors being entirely collinear. So as long as there's sufficiently very high degree of correlation between two vectors, as long as they are non-collinear, it makes sense for me, or it works for me. Jैसे मान लो income and wealth, they are two variables which will move very clearly linearly with each other. So they'll have a very, very high correlation coefficient amongst them. But as long as that correlation coefficient is not equal to 1, we are fine. That is, as long as they are not collinear, I'm fine with that. Is that clear?
Okay, so there is no any like कोई ऐसा standard नहीं है sir degree, right? कि इसके ऊपर होगा तो accept
Exactly. Degree depends from researcher to researcher. How much degree of correlation he or she is willing to have as far as his or her model is concerned.
Oh, okay, sir. Thank you.
Anyone else has any other questions?
No, sir. Thank you.
Okay. All right then.
Thank you.
Yeah. All right then. Please come. At least read some of the assumptions. Prior to coming in the class, so that you और भी अच्छा हो जाएगा और आप और भी questions पूछ सकते हो, because this is one of the very important portion as far as CLRM is concerned. And once you move from CLRM to all those maximum likelihood estimators and all, तो वो चीजें और भी easy हो जाएंगी, क्योंकि these assumptions matter a lot. So that's it. And again, a request: at least devote 5-10 minutes, जितना भी आपको time मिलता है, just as a leisure activity, just try learning R yourself. And trust me, like application of Econometrics along with R software, nothing like it. You'll never feel less confident about this subject at all, wherever you are. So, see you all in the next class. Thank you so much for being today. See you all in the next class. Stay safe.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.